Math 1342, Section 1.3, Experiments and Observational Studies, Video 1, Association and Causation. I do expect this video to be a little bit longer than the previous one because there are several examples that we're going to look at. All right, so first let's take a look at some scenarios to kind of get the idea of association and causation, and then we'll define each one. A professor at the local college has been looking at recent heating bills and comparing them to data on average outside temperature. Not surprisingly, when the temperature is lower, her heating bills tend to be much higher. She wonders, it's going to be an especially cold winter. Should I budget for higher heating cost? So this professor seems to be thinking that there's some sort of relationship between the temperature outside and the heating bill. Do you think that's a reasonable thing to conclude? In another scenario, the plant manager for a large manufacturing plant has also been looking at heating data and noticed that when the building's heating plant is used, there are more employees missing work due to back pain or colds or flu. He wonders, could emissions from the heating system be having an adverse health effect? Could emissions from the heating system be having adverse health effects on the workers? So do you think that's reasonable? And finally, the local highway superintendent is looking at data on the amount of salt spread on the local roads and the number of auto accidents. In parts of the country where icy roads are common, it's pretty common to spread salt to increase traction. The data clearly show that weeks when lots of salt is used also tend to have more accidents. He wonders, should we cut down on the amount of salt we spread on the roads so that we have fewer accidents? He's looking to see if there's some relation between the amount of salt they spread on the roads and the number of accidents. Each of these situations involves a relationship between two variables. In each scenario, variations in one of the variables tends to occur in some regular way with changes in the other variables. Lower temperatures go along with higher heating cost. More employees have health issues when there is more activity at the heating plant, and more salt goes with more accidents. When this occurs, we say that there's an association between the two variables. An association. Two variables are associated if values of one variable tend to be related to values of the other variable. Now be careful. I'm not saying that one is causing a change in the other. I'm simply saying that there's an association between the two. The three neighbors, and by the way, these people were neighbors, share a desirable habit of using data to help make decisions, but they're not all doing so wisely. While colder outside temperatures probably force the professor's furnace to burn more fuel, do you think that using less salt on icy roads will make them safer and cause less accidents? The key point is that an association between two variables, even a very strong association, does not imply that there is a cause and effect relationship between the two variables. Causation. Two variables are causally associated if changing the value of one variable influences the value of the other variable. And again, the difference between causation and association. Association means that these two values seem to be changing at the same time. Maybe one goes up and the other one goes down, or maybe they go up at the same time or go down at the same time. Whereas causation is saying not only are they moving simultaneously, one of them is causing the move in the other. In other words, a change in one value is causing a change in the other value. It's important not to confuse association with causation. Let's take a look at some examples. For each sentence discussing two variables, state whether the sentence implies no association between the variables, association without implying causation, or association with causation. If there is causation, indicate which of the variables is the explanatory variable and which is the response variable. Let's highlight everything we're being asked to do here. State whether, excuse me, the sentence implies no association. Oops, that's not what I meant to do. One second, folks. I meant to draw and highlight here. So our answers are going to be either no association between the variables, association without implying causation, or association with causation. If there is causation, explain which variable is the explanatory, which one's creating the change, and which one is the response variable, which one is responding to the change in the explanatory variable. Now, let's take them one at a time. A, studies show that taking a practice exam increases your score on an exam. Is this implying some sort of association? Meaning when one value changes, the other one changes as well. Well, practicing increases your score. The more you practice, the higher the score. So not only is it an association, but it's implying causation. It's implying that taking the practice exam will cause your score on an exam to increase. The sentence implies that in general, taking a practice exam causes an increase in the exam grade. This is an association with causation. The explanatory variable is whether or not a practice exam was taken, and the response variable is the score on the exam. Pardon me for a second. Forgot to hit the space bar. All right, let's take a look at B. Families with many cars tend to also own many television sets. First off, is there an association being described? Many cars, many television sets. It is implying an association there, meaning that they're both kind of moving in the same direction. But is it implying causation? In other words, is it saying something like, if you get more cars, then you will have more television sets? It's actually not saying that. So we seem to have association without implying causation. The sentence implies association since we are told that one variable, the number of TVs, tends to be higher when the other number of cars is higher. However, it does not imply causation since we do not expect that buying another television set will somehow cause us to own more cars, or that buying another car will somehow cause us to own more television sets. This is association without causation. Now, in the next video, we're going to talk about confounding variables, meaning that there's a third variable not being discussed that might be associated with these two variables and actually have a causation. So can you think of a third variable that might be associated with having more cars and having more television sets, a third variable that might actually cause you to have more cars and more television sets? Yeah, I think that variable would be your salary or how much your income is. It would stand to reason that the higher the income, the more cars you may have, and the higher the income, the more television sets you may have. That would be causation. All right, C, sales are the same even with different levels of spending on advertising. So our variables are a number of sales or amount of sales and level of spending on advertising. Is this suggesting an association? Well, it's saying that if we change the different levels of spending on advertising, we don't seem to be changing the sales. So one of them moving doesn't seem to have anything to do with the other one moving. This one is not even an association because sales don't vary in any systematic way as advertising varies. There is no association. 3 more examples. D, taking a low-dose aspirin a day reduces the risk of heart attacks. No association, association without implying causation, or association with causation. Is that how it was phrased? Association with causation. Which one do you think it is? Well, it's saying taking a low-dose aspirin, so increasing the aspirin intake, and risk of heart attack goes down. So they're changing. So they're changing simultaneously, one going up, one going down. So it seems there's to be an association, but is it implying causation? Actually, it is. It's saying taking an aspirin, increasing your aspirin intake reduces or causes a lower risk of heart attacks. So this seems to be in causation. association with causation. The sentence indicates association with causation. In this case, the sentence makes clear that a daily low-dose aspirin causes heart attack risk to go down. Oh, I forgot to ask which is the explanatory and which is the response. The explanatory is the aspirin intake, and the response is the heart attack risk, meaning that your heart attack risk responds to the amount of aspirin that you take, and vice versa. The amount of aspirin that you take explains the change in your heart attack risk. All right, E. Goldfish who live in large ponds are usually larger than goldfish who live in small ponds. The two variables are the size of the goldfish and the size of the pond. Is it implying an association? Yes, it's saying larger ponds, larger goldfish, and vice versa, smaller ponds, smaller goldfish. But is it implying a causation? Well, no, it's just saying big fish live in big ponds, small fish live in small ponds. So this seems to be association without causation. The sentence implies association, but it only states that larger fish tend to be in larger ponds, so it does not imply causation. In other words, it doesn't say if you put a fish in this pond, it will get bigger or smaller according to the size of the pond. F, putting a goldfish into a larger pond will cause it to grow larger. This is clearly an association with causation. Why? Because it's explicitly saying that if you put this goldfish into a larger pond, it will cause the size of the goldfish to grow. The explanatory variable is the size of the pond, and the response variable is the size of the goldfish. I believe that wraps up this section, this part of section 1.3. In the next video, we'll elaborate a little bit more on confounding variables and anything else in this particular section.